he will help us to organize the event. So he's having a lot of experience in that area. So he will talk about DSS and he will tell more about it.
First of all, I would like to thank all of you that you're here tonight. I would like to thank also to the guys from the Exam Society for all the time and effort they put to make this event happen. And I would like to appreciate also the great work with the presenters before me actually. So thank you all guys. So Alex. Asparuk and Juan is not here because he's secretly good. Asparuk is not here because he's sick, but still he was here to do his presentation.
Is it better now? We have some technical issues, so give me a second.
Okay, I am here with Mitov. I work at JQ, and I'll talk about real-time analytics with age-based. I'll give you some real use case of age-based composition framework, so you learn how you can use it for complex event processing and some situational analytics. So, I'll give you a little bit of context information. The one solution which I described was for one really big telecom, and as such, it has different instances in different countries. So the project was Integration Gateway. For those of you who don't know what is the Integration Gateway, it's just a gateway which organization used to expose services to outside world and partners. So usually Integration Gateway implements the following functionality as authentication, authorization, dropping, routing, transformation, orchestration. And on one hand we have multiple partners, and on the other side we have multiple backends which are actually implemented in different countries, and behind each of these backends actually you have multiple systems. So all the communication between these components actually happens asynchronously, and it passes over the message bus. And the challenge was that one had very high volume data, so they had something like 10,000 incoming messages per second. Okay, so initial plan, the plan was to use Nagios for monitoring, which is pretty nice operational tool, and they plan to use Oracle as a source of information. So their initial plan was pretty simple. They just wanted to input all the data, passing through the message bus inside Oracle, and later retrieve the information real time with accuracy. But it happens that because of such a volume of data, so I didn't mention, but you can imagine that if you have one message coming into the system, this message actually produces a lot of internal messages, roughly around 10, let's say. But that's kind of average. So, after they found that it's quite impossible to store this data in Oracle, and they was advised to use the tool. So, they was able finally to input all the data passing through the message bus inside the tool. And they had really nice MapReduce draw, so there was a way at least to know what the customer actually used. And they also started to run some analytics on the top of it. So far so good, but they had a problem. The problem was that they decided to sign a contract with one very big content supplier, also service supplier, I would say the biggest one. So customer was allowed to purchase a mobile application, and their bills will be applied to their services. So they will pay this mobile application with their monthly bills. But it happens that because of the complexity of the system, sometimes particular segment of customers was not able to be served. And because of lack of this real-time information, it happens that this big organization, actually the service provider, informed the telecom in advance. So it was very inconvenient for the higher manager. You can imagine that it was not very pleasurable to receive a call, your service is not working, and nobody actually realizes. So, we decided to use HBase. For those of you who don't know what is HBase, it's actually a big table implementation. It's fast-distributed, persistent, multidimensional sorted map. It sounds pretty complex, but actually it's not. So all of you know what is a map. It's just a sorted map, so the keys are sorted. It's multidimensional, means that actually you have kind of path in order to reach the value. So path is usually row K, column family, column modifier. You have version, and in the cell you have of course the value. It's a column-oriented database management system on the top of HDFS. In general, because my client actually bought their implementation, which was not using HDFS, but their own specific file system. Okay, that's kind of my initial overview of what is HBase, and it's important because you find why this was very good suit for the problem which we had. And the problem which we had was actually to provide a real-time correlation of such a volume of events. So, okay, usually we have some clients API, we have external APIs, we have some master, which is responsible for detailed operations like creating tables and setup of the region. For those of you who don't actually use HBase, a regional server is actually the main component. It's co-located with data nodes, so you achieve data locality if you deploy this cluster. Each regional server usually has some right network. It's used in order to achieve strong consistency. And each regional server actually manages multiple regions. Region is just a piece of software which is responsible for particular key range. And you have mail store, which is needed because all this data, as mentioned, is sorted. So first data processing is in memory, each operation is stored in the right network, and at some point the mail store is pushed to the H file. Okay. HBase has some really nice feature named Processing Framework. This allows actually to put your own code inside the HBase. So you can think about there are actually two types of coprocessor. One is endpoints. You can think about endpoints like kind of XP and or store procedure in classical relational management system, everything. And you have also observers, which are kind of triggers actually. So you can put particular events happens in the HBase. So there are multiple types of observers. So depending on the type of events which you actually would like to put, you can use different kinds of observer. This one I think is pretty useful because you can hook events like put, which means that you can treat, you can handle data before it's actually inserted into the table, or afterwards inserted, or deleted, or scanned, and okay, you have also ability to influence the way how the WAV file is used. because we are a little bit out of time. So let me describe a little bit the solution of the problem. So as I mentioned, the client was willing to have some system which will allow him to somehow define the KPIs and retrieve the information real time. So first of all, we decide to view the model and we have something named attribute descriptor. It's pretty simple, means some way to extract logic or let's say field from the event. We have also method definition, which is kind of set of attributes, and also type. For this client, they requested only two types of metrics. One was pretty simple count, and other was legacy type. And we also have channel adapter in order to support the events passing through the message bus. We have something called message manager, which is actually managing attribute and method definitions, and of course we have HBase gateway. So let me describe the schema. Schema is actually very important to the way how you deal with your data in HBase. As I mentioned, actually in HBase you have key, you have data family, you have column qualifier, you have also version. So we decide to define attribute tables in order to store different kind of attributes or the name. So and we have value and ID. So name was the primary key, value was the phone name, and ID was what we stored through the cell. So for the metrics, we have something similar. So primary key name of the metric, and phone was just type of the metric. So in this case, latency or count, list of attributes, and of course ID. So it's important to mention here that it's not only the definition of attribute, but it's also an instance. So this value is what actually is extracted from the real message coming over the message bus. And why this is important? It's important because somehow we have a lot of such instances. And why this is important? Because HBase actually have one really great functionality. In case that particular table grows up to some limit, table will be split and distributed, so it will be kind of elastic distribution of the work. And there are some tricks. If you have some data which is kind of constantly growing, like order, like this one, and in order to make this work actually, we have in front of this table just different ID which is we have here. And in practice it happens that we have something like 10,000 metrics, okay, not really 10, but between 7 and 10, something like this. And the work was, let's say, pretty good distributed along the coastline. Okay. So this was table which we used to store actually the aggregation results, and this was actually optional, and it was used to guarantee consistency. So when it has that particular instance of HBase goes down for some reason, we was able to recalculate only particular transaction. Okay, for I didn't mention probably what are these things, and then probably for. Okay, so transaction ID is actually the ID of the message, which message initially entered in the system. So it's used to correlate all of the messages which are related to particular partner request. Okay, correlation ID. It's pretty obvious, just ID is used to correlate request and response of particular message. Okay, good. So we decided to implement a particular coprocessor, and this is observer actually. So what we did was to create a coprocessor which is actually sitting in this regional server which I mentioned before. So when you put something, you have, let's say we have some event, we add an event into each region, and before we actually after the event is stored into the table, we try to correlate this event with the previous event, which are for the same correlation agent. And it was extremely efficient because HBase stored this information for some time in memory in this main file. So most of our request, or roughly about 85%, was actually served from the information which was in memory at this point. It was very, very efficient. So we did something really simple. We did a loop. So for all the metrics which was final user, we created some entries and put this into the metrics table. And on the metrics table, we had something similar. We defined also some observer, and it was probably a little bit implementation detail. It was used to recalculate the metric value, and then so in that we had a system which was able to process runtime such a volume of messages. It was able to correlate request and response, and it was very efficient actually. So in the just five servers was able to process all the incoming code. It was very very efficient actual implementation because it took just 3 months from architecture to production. I personally think that HBase and coprocessor are not so famous, but there are great ideas behind it. So I just wanted to make sure that you're aware of what you can use it, what it's useful for. Thank you.